One benefit that I hope you receive from our study of logic in Chapter 3 is that you become a better critical thinker and critical listener and speaker. Logic and mathematics make you really look at the individual details before you make conclusions about, for example, speeches that politicians make or articles that medical professionals may make. This can also help you guard against deception. In this section, we're going to look into a specific case or a case study of junk mail deception. Maybe you have found yourself in this situation. Example 7. Suppose you receive a letter in the mail with the following claim. If you follow the instructions inside this envelope and return the winning number, then you win $7 million. Sounds pretty easy, right? Sounds like I just need to follow instructions, take the winning number that they've sent me and return it and collect my $7 million. But let's examine this logically to see if this statement is always true. We're going to use our skills to break this compound statement down into simple statements, translate it to symbolic form, and then analyze it with a truth table. Then we'll be able to make a sound conclusion. So notice our statement begins with if, so it's a conditional statement. If you follow the instructions inside this envelope. Now, you follow the instructions inside this envelope is a simple statement. We'll define that as P. Next, we have a connective and you return the winning number. We can define that as statement Q. Then, here's the conclusion of the conditional. You win $7 million, and we will call that statement R. Let's convert this to symbolic form. So here's the point where we go from the English language into a mathematical or algebraic form. We have a conditional, which means we have this one direction arrow. On the left of the conditional, we're going to symbolize our hypothesis. That is, you follow the instructions inside this envelope, that's statement P, and we can write our symbol for and. You return the winning number. That's statement Q. So that follows the word if. That is the hypothesis of our conditional. The conclusion is you win $7 million. That is statement R. Now that we have this statement in algebraic or symbolic form, we can apply the rules of our connectives using this truth table to more closely examine the nature of this statement. Notice we have 3 simple statements, therefore we need 8 rows. We have 3 simple statements plus 2 connectives, so we need 5 columns for our truth table. Now, in an 8-row truth table, remember we set it up in column 1 with half T, half F. That is 4 T's, 4 F's. Then in column 2, we split that into 2 T's, 2 F's, 2 T's, 2 F's. And finally, in column 3, we're going to repeat this true, false, alternating every line. And as you've learned, our entire compound statement is the destination of this truth table. That is our goal. So to judge the truth value of the conditional, we need to know the truth value of the statement on the left. That is our conjunction, P and Q, and we need to know the truth value of the statement on the right, and we will have that in this column here. So let's go ahead and use the rules for connectives to fill out our truth table. Now, we are looking at a conjunction here, an and. An and statement is going to be true when both components are true. And the 2 components we are considering here are P and Q. In rows 1 and 2, both components are true. In rows 3 and 4, you have only one true, therefore the conjunction is false, right? In rows 5 and 6, you've got one component false, one component true. Your conjunction is false. And then finally, in rows 7 and 8, the last 2 rows here, both components are false, therefore our conjunction is false. Now we're ready to judge the truth value of the conditional statement. So we're looking at the rules for a conditional, and remember, this is the case we look for. If true implies false, then the conditional is false. But be really careful. We're going to go from the hypothesis, P and Q, to the conclusion R. So we need to go from this column to this column in order to obey the direction of that arrow. So in row 1, we have true implies true. That's true. Row 2, that's the one we look for. True implies false is false. Row 3, false implies true is true. Row 4, false implies false is true. Next row, false implies true is true. Now remember, if I read that the wrong direction, I would get the wrong conclusion. So it's really important that I go in the right direction. False implies false, strangely enough, is true. False implies true is true, and false implies false is true. Judging from the last column in this truth table, is this statement a tautology? Is it guaranteed to always be true? No, there is a situation where the statement is false. If we look at this false conclusion, it's under these specific conditions. So under what conditions is the statement false? Well, P is true, Q is true, and R is false. Let's go back and see what that means. If P is true, you follow the instructions, right? And if Q is true, you return the winning number. If R is false, that means you do not win the $7 million. So you follow instructions and return the winning number, but you do not win the $7 million. And you are mad. Why? What happened? Well, the key is that word right there. You have to return the winning number. The number that you received in the envelope is more than likely not the winning number. The statement sounds like, if you follow the instructions by returning the winning number that you will find inside the envelope, then you win $7 million. It sounds very simple. However, what if no winning number exists? Is it still possible that the company could never award the $7 million and still be legal? This is why we have regulations for lotteries and sweepstakes and games and game shows, because unless you read the fine print, if you apply the logic to understand the rules of the game, then it can be very deceptive. So one thing our study on logic helps us to do is to read critically, understand how statements are formed, and use that to guard against deception. I hope you found that interesting. Next time you get that envelope in your mail, think about contemporary math.